Hello, and a very warm welcome to Cognito Key. Have you ever stopped to think about how we measure something we can't even see, like electricity, with such, well, pinpoint precision? Today, we're going to dive into the amazing story of how we moved away from those shaky, flickering needles and started getting solid, crystal clear numbers on a screen. And it's all thanks to one incredible little device.
I mean, think about it. It's kind of like trying to bake a cake, a really precise one. But your measuring cup just has these vague, fuzzy lines on it. That's pretty much what engineers were dealing with using old analog meters. You've got this needle just hovering somewhere, and a tiny misread, a little wobble. That could be the difference between a circuit that works perfectly and one that's totally fried. But then, boom, everything changed. Let's look at the invention that brought some much-needed clarity to electronics.
So, what exactly is this game-changing device? Well, it's time to officially meet the star of our show, the Digital Voltmeter. Okay, so a digital voltmeter, or DVM for short, pretty much does exactly what it says on the tin. It measures voltage and then it just gives you a number. A direct, precise number. You don't have to squint at a needle anymore, wondering if you're reading it right. Just that simple switch from a moving needle to a plain old number got rid of all the guesswork. And that was a massive leap forward in accuracy. Now, this amazing invention didn't just pop up out of nowhere, right? For a long, long time, the only option we had were those, well, tricky analog meters. But then in 1954, this one innovator, Andrew Kay, completely changed the game. He invented the very first digital voltmeter. And from that point on, honestly, electronics took a huge leap. Today, good luck finding an electronics lab that doesn't have one. They're absolutely everywhere. Okay, so it's one thing to know what a DVM does, but how does it actually do it? How does it perform this little bit of magic? I mean, how do you turn an invisible force like voltage into a number on a screen? Well, let's pop the hood and see what's going on inside. We're going to follow a signal on its journey from analog to digital. So, the whole process is actually pretty straightforward, really. It all happens in just 4 key steps. First up, the DVM gets the input signal, the voltage, and it scales it down to a safe level it can actually work with. Then comes the really cool part, the conversion. An analog to digital converter takes that smooth, continuous analog signal and chops it up into digital pulses, zeros and ones. It's a bit like how a digital camera turns what it sees into pixels. After that, a counter. Well, it counts up all those digital pulses. And finally, that total number is sent to the screen for you to see. It's a really clever and elegant little system. So, we mentioned a decade counter. Now, I know that sounds super technical, but don't worry, it's actually a really simple idea. All it is a counter that counts in groups of 10. Just like we do. And because it does that, it makes it incredibly easy to turn that digital count into the regular numbers we see and use every day. Now, once engineers cracked this basic idea, turning analog into digital, they didn't just stop. Oh no, they got really creative. They came up with a whole bunch of different ways to get the job done. And each method has its own clever little twist. It really just goes to show you there's almost always more than one way to solve a problem. So here are 4 of the most common ways DVMs pull this off. First, you've got the ramp type. Think of it like a race against a clock. It measures how long it takes for a generated voltage to match the one coming in. Then there's the dual slope method. This one's like filling a bucket with water and then measuring exactly how long it takes to empty. It's super accurate. The integrating type is also cool. It turns the voltage into a frequency, a stream of pulses. The higher the voltage, the faster the pulses. And then there's my personal favorite, successive approximation. This one is like a game of 20 questions for electronics. The DVM makes a series of really smart guesses to zero in on the exact voltage, super fast. See? They all get to the same answer, just in their own very clever ways. So, with all this clever tech packed inside, you might be asking, what's the big deal? Why did the DVM become the absolute must-have tool for pretty much everyone working with electronics? Let's break down the advantages that really made it a total game changer. And the benefits are, well, huge. First off, it completely eliminates those human errors. No more second-guessing a wobbly needle. The reading is the reading. They're also incredibly fast. You get results instantly. But honestly, the real revolution, the biggest deal of all, is that you can feed that digital output straight into a computer. That opened up a whole new universe of data storage and analysis. And of course, they got smaller and smaller, so now they're super portable. And just to give you an idea of how accurate we're talking, a typical DVM is accurate to within plus or minus 0.5%. Now, to put that in perspective, that's like measuring an entire football field and being off by less than the width of one blade of grass. It's that kind of incredible precision that makes the DVM the trusted tool for even the most delicate, most demanding jobs in electronics.
So here's something to think about. The next time you pick up your phone, or start your car, or even check the weather, just remember the humble digital voltmeter. Because the very same core idea that changed the electronics lab is now literally all around you, all the time, quietly turning the analog world into digital data. It kind of makes you wonder, doesn't it? How many of these invisible translations are happening around us every single day that we don't even notice?
We really hope you enjoyed this little trip into the world of the digital voltmeter. If you found this explainer interesting or helpful, we would so appreciate it if you could hit that like button, maybe share it with a friend, and of course, subscribe to Cognito Key for more deep dives into the amazing world of tech. Thanks so much for watching, and we'll see you in the next one.